Good afternoon once again, gentlemen, and welcome back to our topic, differentiation, which we introduced today. I want us to continue so that we are able to get something that can help us start solving a few problems here and there. But I want us to go back a little to what we talked about earlier, about the difference between differentiation and integration. And I want to give a simple analogy. Because remember, we have said it is a reversing the process of differentiation. Suppose you want to put on shoes in the morning. You have woken up, you want to put on shoes and socks in the morning. Which one do you start with? Do you start with shoes, then socks, or socks, then shoes? The correct process is you put on the socks first, then shoes. And when you come back to the house, maybe in the evening, you want to change, you want to remove your shoes, you don't start by removing socks. You remove the shoes first before you remove your socks. So I want us to look at this, our table that we looked at earlier. We said that in differentiation, as we were doing it, you multiply each term in the function by the power. That is what we were starting with. The next process was to subtract 1 from the power of each term of that function. Now, when we reverse this process in integration, we start by adding 1 to the power. Remember, we had subtracted 1 from the power in the last stage in differentiation. Now, we add 1 to the power because we want to go back to where we started. Add 1 to the power for each term of the function. Then finally, we divide each term of the function by the new power. Remember, we had multiplied by some power. Now to remove that term, we have to divide each term of the function by the new power. And I'm talking about dividing each term because we are going to have functions that have more than one term. Now, we say that in general, if we are given a derived function dy dx is equal to x power n, then y, the function now, is equal to, this is a function in one term only, x power n. So we add 1 to that power. Our new power is now n plus 1. We divide by that new power, which is n plus 1, plus a constant. If we are looking at real examples, n would have a value, and so the next stage from this would simply be simplifying. We have already integrated. So I want us to look at a few examples here so that we are able to understand the concept of integration. Suppose we are to integrate 7, meaning that we are given a derived function to be 7. We start by saying dy dx is equal to 7. Then we remember this our process. If we have 7, then it means it is 7x to power 0, because any number raised to power 0 is 1. That is why that x is silent in 7. And so you can see here, the original power of x is 0. To that power we add 1. Then we divide by the new power, which is 0 plus 1, plus a constant. When we simplify this, we shall have y is equal to 7x plus 7, plus c. So the derived function 7 came from a function of the form y is equal to 7x plus 7. And like I said earlier, if you were to differentiate this, you will get that dy dx is equal to 7 because the derivative of this constant is going to be 0. Look at our example number 2. (2x plus 4). So we are saying that means dy dx is equal to 2x plus 4. Like I said in the morning, gradient is not constant all the time. Particularly now when we talk about gradient of curves, it is changing from point to point. So if we have a gradient function of 2x plus 4, it means the function could have been a curve. So where was the function? We now integrate. But remember, I said some functions will have more than one term. This one has 2 terms. So the process of integration is done for every term. Start with the first term. The power of x is 1. Normally when the power is 1, we don't write that 1. But now when we are integrating, because we are supposed to add 1 to that power, we must therefore write the original power, which was 1, plus 1. Then we divide that term by the new power, which is 1 plus 1, plus x had a power of 0 in 4. That is why that x was silent. So we must now write that 0 because we want to add 1 to that power. So 0 plus 1 divided by 0 plus 1 plus a constant. The next stage is simply a process of simplification. You can see 1 plus 1 becoming 2. 1. Now to write a simplified general function, we have y is equal to x squared plus 4x plus c. So this is the general function from which we got this derived function. Next example, we are now moving to many terms. You can see now we have 3 terms. We have a derived function that has 3 terms. So from where did this derived function come? So we integrate each term, and the process, you can see we start by saying if dy dx is this, then what is the function y? So for each term, you can see the first term, the power of x is 3, so we add 1 to that 3, so 3 plus 1. Then we divide by that power of 3 plus 1. Here, the power of x is negative 4. We add 1, we divide by negative 4 plus 1. Plus, here, the power of x is 2, so we add 1 to 2 and divide by the power 2 plus 1 plus a constant. The next step is simply simplification. You can see the power of x will be 4, we divide by 4. The power of x will be negative 3, here we divide by negative 3. The power of x will be 3, we divide by 3. Further simplification gives us this last step. I want you to note the second term, where we have changed from negative to a positive because we were dividing negative by negative 3. So the result for that term is now positive 2x power negative 3 over 3 plus x power 3 plus c. The next example, look at this. We have not seen this in the past 3 examples, but I want you to know that even this is as simple as the others. But we must work through some process again. You remember indices? We can only integrate these terms when we do away with the fractions. And one way of doing away with these fractions is converting them using negative indices. So if we have 1 over x power 3, that is the same as x power negative 3. If we have 1 over x power 4, That is the same as x power negative 4, if you remember our indices in form 2. Now that we have them as powers and we have no fraction anymore, then we can now integrate to get the function from which the derived function was found. As usual now, the first term has a power of negative 3, so we add 1 to that power. We divide by negative 3 plus 1. The second term has a power of negative 4. We add 1 to that power, divide by negative 4 plus 1, plus a constant. Remember, these are general functions. The next step is simplification. We have a power of negative 2, so you divide by negative 2. We have a power of negative 3, so we divide by negative 3, plus a constant, and then the final function becomes this. You remember now that we say that if we are dividing by negative, then now it will be negative x negative 2 over 2. The negative that we had in the denominator has gone to negative x. Then in the second term, you can see in simplification, we were dividing a negative by a negative, so the result is positive, plus c. So let's look at the next example. In this example, we have a function, a derived function that is given in quadratic form, in 2 brackets, that we need to expand first. So we are expanding 1 minus 4x into 1 plus 4x. I want to inform you that anytime we are given a function that is supposed to be expanded like this, the process must be expanded first before we embark on integration. This is a simple expansion, but I've taken you through just one of the steps, multiplying 1 by the other bracket, negative 4 by the next bracket, but the result after simplification will be 1 minus 16x squared. At your time, I want you to take time and expand so that you arrive at 1 minus 16x squared. But now that we have 1 minus 16x squared as the derived function, then now you can see that 1 has a silent x because that x was to power 0. So we add 1, we divide by 0, 0 plus 1. 16x power 3, we have added 1 to 2, so we have 3. Divide by 2 plus 1, plus a constant. You can simplify in the next step, and finally we end up with y is equal to x minus 16x power 3 over 3 plus a constant. You can see the processes through which we have gone. It is a simple process that I want to take time and just follow. Follow each of the examples we have done. Where there is need to simplify before integration, please simplify first, then integrate term by term. I want you to go through the homework in KLB book 4. There's a lot of work there that can help you go through this topic, the first part that we have done. KLB book 4, the 4th edition, questions number 1 to 4. Very diverse questions you can go through. Do them, and where you have a challenge, you are always free to send your questions. We can be able to answer them in our next class. But you will find that it's a very simple process that if we take and do following the examples that we have done here, you will find this to be, as I promised you, the easiest topic in this world. I want to thank you very much for listening to me, and may God bless you all.